Let's take a brief look at object-oriented programming with Python and the use of classes. So object-oriented programming combines data and actions or methods. So you have instances of a class that contain data that are specific to that instance, and then methods that are accessible by all members of the class. So the class just provides a general framework and structure for the objects that we will be using. And an instance is a specific member of the class. It has, again, the general structure of the class, but specific data to that instance. So let's take a look at a dog class. In Python, we create a class by using the word class. This is one of the few instances when a variable name is capitalized with the first letter. Classes, when you see a capitalized letter in Python, you can almost certainly expect that it represents a class. And then inside the brackets, the word object there is telling Python that this is following the general object description in Python. You can put other things there to do what is called inheritance, where you can reference something else, another class that has been created. But this is the general object idea that is fundamental in Python. We typically, again, have a docstring at the top that will describe what the class does. The same kind of idea that docstrings in functions describe what a function does, or a docstring in a method that we'll see in a bit that describes what that method does. That way, if there's another user who's using something you've written, it's easier for them to tell exactly what's happening and what's going on. Okay, so when we create a class, we will start with the name of the class. So what we have here in this case is dog. And then we create what's called a constructor. So the constructor for the class is what we will put into place when we are wanting to create an instance of the class. So what happens looks like a function. It has def. Inside a class, a function is called a method. So this is a constructor method. The two underscores before the init, so it's initializing. The two underscores before and after are part of the method name. And this is an example of what in Python is called a dunder method. Dunder meaning double underscore. And so there are several methods that are built in that have specific meaning, specific purposes. And so we'll see a few of those now. But if you create other methods that aren't one of these specific methods that are already established as a dunder method, then you don't use the double underscores. You would just use a regular naming convention. But again, remember that it is legal to begin a variable name in Python with an underscore. The only thing that you can't begin with is a digit, but you can create a variable that starts with the underscore, and in this case, this method is a double underscore at the beginning and at the end. The next part then, self, is referencing the particular instance that we're going to be creating, and so that is part of all of our methods that we will create inside the class. And then otherwise, we might have some other kind of values that we assign. So we may have name, breed, color, weight, whatever the information that we would want to keep track of with the instance of the dog class. And then these become attributes if we assign those values. So we need those when we create an instance of the class, and then we need to do something with those. So for example, we could do something like self.name, and then assign that value of self.name to be whatever name the user had given. Then we could do the same thing with breed and color and weight and so on. So self.breed, self.color. Again, we don't have to name these the same thing. We've named them that way so that the user can see what the input values, what the parameter represents, and then we're assigning that same name inside the class just so it represents the thing that the user would have been inputting data to represent. So color, weight, and so on, we can assign those. And now when we create an instance of the class, then those values are automatically associated with that particular instance. So outside the class, if we created a new variable and called it dog_1, this is again outside the class, we would create an instance of the class by assigning that to be equal to dog with the capital D, and then give those 4 values that we asked for. We don't have to give it self. Self is actually representing this instance of the dog class, but we give it a name, and in this case we called it Georgie. It's a collie, its color is sable, and it weighs 14.5 kilograms. If we then print dog1's name, we would see Georgie. If we print its breed, we would see collie. Those are assigned according to their position in the constructor. We could create another dog, a different dog with a different name, a different breed, and so on. If we print the corresponding attributes, then we will see those appropriate values. We could also do something like create a list of dogs. And so we have dog1 and dog2, which we have already created. And now we're adding a new dog that we hadn't created separately. So we don't have a separate variable name for this dog, but we've created Bob, an Australian Shepherd. And then if we look at, say, a loop, we could loop for dog and dogs. Again, notice that the dog here is a lowercase dog, so it doesn't represent the class. It represents an element in the list that we have named dogs. We can say something like, if the dog.weight is greater than 20, then we'll print that dog's name. And so it would go through the list. It would look at dog number 1 and look at its weight and see that its weight is only 14.5. Dog number 2, its weight is 28, excuse me, so it would print Owlus at this point because that is that dog's name. And then on the third dog, it again weighs more than 20 kilograms, so it would print Bob in that case because that is that dog's name. So we're able to access data about different instances of the class by using this dot notation to access the attribute. We could also print the name of the entry in index 2, and in that case, again, the entry in index 2 is, the corresponding name is Bob, and so we could see that dog's name. So let's look at a different class, and now let's do something more mathematical and think about a fraction class. So it's going to start off the same, and we have, in this case then, rather than dog, now we're talking about fraction, and again our docstring describes what this class will do. In this case, the constructor will have 2 numbers that we will need to give. When we create a fraction, we give it the numerator and the denominator. Now, typically, we want the numerator and denominator to be integers, so we might specify in the constructor that these are integers. We also might want to rule out possibilities of the denominator being 0. And so if the denominator is 0, then for error handling purposes, we may raise an error, raise what is called a value error in this case, and say the denominator cannot be 0. What would happen then is if someone tried to create a fraction with a 0 denominator, then there would be an error that would be created, and it would say you can't do that, and it would prevent future problems with denominators of 0. Another scenario then that we could look at is if we want to force A and B to be integers, we can check to see whether they're integers. So if B is 0, it is already taken care of. The raise value error will stop the constructor, and it will kick back to the user and give them the error. So we would never get to this next part if the denominator were 0. So now we're saying, okay, we know the denominator is not 0 because we got past that portion. We want to check to see if A is an integer and to see whether B is an integer. So we want both of them to be integers. So isInstance is a function that will check to see if those values are integers. And if they are, then we could set the numerator to be A and the denominator to be B. And maybe we just call those self.num and self.denom. If either one could be an integer, but the other one not being an integer, or neither of them being an integer, then we could raise a type error. This is a different kind of error. The result is the same. The user is told they've made a mistake. But in this case, we could raise a type error that just says both values must be integers. If you want to be more specific, we could separate those out and make sure that they know that the numerator has to be an integer and the denominator has to be an integer. But this portion is part of the error handling that we often build into a constructor to make sure that the entries that the user has given are appropriate for what we want our class to do or how we need our class to behave. If we want to look at addition, let's say, we want to be able to use the plus symbol. To be able to use the plus symbol with fractions, we create another dunder method that's inside the class. So this is tabbed over because it's part of the class. And so the name of this method is the double underscore add. And what happens in this case is when Python sees a fraction plus something with the actual plus symbol, it will look at this method to see how it's supposed to handle that, because otherwise Python doesn't know what to do with this fraction. So we want to look at this and say, okay, well, if the other thing is not an integer or a fraction, in this case, what we're able to do is not isInstance. isInstance is going to check to see whether other is a member of either of these data types. Is it an int or is it a fraction? If it is an int or a fraction, then we're going to describe how to do addition. Otherwise, we will raise a type error that says we can't do that. We'll say something like only ints and fractions can be added to fractions or something. But if the other thing is an int, we will do the addition differently than we would if it were a fraction. Because if it's an int, we think of it like a fraction over 1. And if it's a fraction, we have the denominator there, and we have to deal with that appropriately. So the process of addition will differ depending on whether other is an int or it's a fraction. If it's neither, we're going to tell the user we don't want to, we can't handle that. If it's an int, then what we do is we will get common denominators and add things together. So we'll create a numerator and create a corresponding denominator. So we get the common denominator, which is whatever the denominator of self was. And so we're going to call that one y. And we calculate x, which is then the end result of adding these two fractions together in their new common denominator forms. We're not emphasizing that it is a least common denominator or anything like that at this point. We're just getting a denominator. In the case of an int, it is a least common denominator. But now we have an else that says, okay, if we didn't have an int or a fraction, then we've raised a type error and we break out and it doesn't go any further. If we have an int, we've described what to do at this point. We're calculating a numerator and a denominator. And so the else case is covering the situation of if the other thing is a fraction. So if it's a fraction, then we're still going to get a common denominator. And at this point, it is important that we're not getting necessarily a least common denominator, just one that works. And we're creating, again, an x and a y that is the end result of adding those two fractions together. So now we have, in one of two ways, we have an x and a y that we either got because the other thing was an int, or an x and a y that we got because other was a fraction. And so what we're going to do at this point then is return the fraction x comma y. And so when you see the plus symbol with a fraction plus something else, if the something else is an int or a fraction, then the calculation will be done correctly. And so this dunder add method allows us to do that correctly. Other things that we might want to do with fractions: have a negative, a negation of a fraction, subtract fractions, multiplication, division, so on. So let's take a look at negation. Negation is a situation where we want to use the negative sign. And so because we're going to overload this operator, that's what we're doing with plus and so on, is we're overloading the operator, changing its meaning to do what we need it to do in our particular context. So for the negation symbol, the negative sign, we have a dunder neg, so dunder neg. That one doesn't have another element that's associated with it. It's you just negate the fraction that you already have. And so to negate the fraction, you could return a fraction that has the same values in terms of numerator and denominator as self, but make one of them negative. So return fraction negative self.num, self.denom. So this will return the negative value of whatever fraction you apply it to. For subtraction, so now we have addition and we have negative. And for subtraction, you're going to have an other there as well. And so subtraction, rather than going through all the steps of doing the calculation, we might just return self plus negative other. Now this works as long as someone tries to add something to, or a fraction minus something where the negative sign makes sense. So if a user says, here's a fraction, now let's subtract 7, then self plus negative 7 makes sense. What Python will do is return back to the plus or the dunder add method, right? It sees the plus sign, so it returns to the dunder add method, and it would apply that method appropriately. If the person had put a fraction as the other, so a fraction minus another fraction, then Python would see self, which is a fraction, sees the plus, so it would go to the dunder add method. Then it sees negative of this other fraction and would go to the dunder neg method, get the right value, return that back to the dunder add, do the calculation, bring it back to here, and return the correct value to the user. So there's a lot going on behind the scenes when we have this method in place. Now this doesn't work though if the user tries to say a fraction minus the string hello, because negative hello doesn't mean anything, and at that point Python would have been in the add method, but then would have not known what to do with negative hello, and would have then returned the appropriate error from the string. So not our error, but a different error would have been returned. So these methods, these dunder methods, are allowing us to use symbols in ways, the operators like plus and the negative symbol and the minus sign, to do what we want them to do in the context of our fraction class. And so we might not put this line like this right here, return self plus negative other, because if the user is way off base and trying to have a fraction minus something that doesn't make sense at all, we might want to handle that and account for it. So we might have another line in place that checks to see whether other is an int or a fraction. Then if it's not an int or a fraction, we raise an error. But if it is an int or a fraction, then we have this line to return self plus negative other. So we can reduce the amount of writing that we have to do, the amount of code that we have to write, and take advantage of things that we've already written. So what happens if the user decided to say 3 plus the fraction 1/2? In that case, the 3 plus, Python would be looking at an int and looking at the int dunder add method. And the int dunder add method doesn't tell it what to do if the other thing is a fraction, because we just created the fractions ourselves. So these don't already exist. So what we can do is, in that case, we can tell Python that, okay, if you have something plus a fraction, what Python will do is, well, first of all, look at the 3, look at the int and say, okay, 3, we know what that is, plus, I'm looking at the int dunder add method. It doesn't tell me what to do if there's a fraction there. So what Python does then is it looks in the fraction class to see if it knows what to do. And it will look for this dunder r add method. And so what happens is, at this point we've said, okay, well, if you have an int plus a fraction, treat it as if it were a fraction plus the int. And so what Python then would do would be go to our dunder add method, do the calculation, give that back to here. This then returns the value to the user. And so in the case of adding a fraction, if you have a fraction plus an int, it's the same answer as an int plus a fraction. And so we have both ways accounted for, but it tells Python what to do in each situation. Python doesn't know what we mean to happen, and so it won't assume what we mean to happen. If we haven't specified exactly what we want to have happen, then it won't do anything, give an error message, or will, in certain scenarios, do a miscalculation. Now, in this case, with the add, it doesn't matter whether the fraction were on the left-hand side or whether it was on the right-hand side. We get the same answer. But if you think about, say, some multiplication situations, for instance, if we multiply a vector times a matrix, that's different than a matrix times a vector. So we will also have like a multiplication and then an R multiplication that will do different things in the different settings. So we do have to be careful sometimes that the location of the element or the instance of our class, whether it's on the left-hand side of the operator or on the right-hand side of the operator, can make a difference in how that calculation is carried out. So again, we mentioned multiplication. So multiplication dunder method is MUL. And then there's the RMUL if the element, the instance of the class is on the right-hand side and something different is on the left-hand side. There are times when we don't want to be able to do a calculation when things are in the wrong order like that. So sometimes we only want something to be permissible if it's in one place, and so we won't have the other method. Or if we have the other method, we just have it there to return an error message. Division is different in terms of the name. Division, rather than just being dunder div, is dunder truediv, and this will do use the division symbol the way that we want. And there's some carryover reasons, div meaning something used in a slightly different way. So we won't get into that at this point. If we want to check for equality, if we want to see whether two fractions are equal to each other, this is using the double equal sign that we use in conditional statements. There's a dunder EQ method for that. And so when you think about writing this method, you say, what could we do? How would you check to see whether two fractions are actually equal? So at this point, we haven't done any calculations with fractions to know what the number that corresponds to the fraction is. We have the numerator and the denominator. So to check to see whether two fractions are equal, we can't just check to see if the two numerators are equal and the two denominators are equal. Because, for instance, 1/2 and 2/4 are the same value. So there are different ways we could do the test for equality. And there are pros and cons to different ways of implementing this test. But one way would be to convert them to numerical values, and you can convert to numerical values by using this dunder float method. And you think about it, okay, I know the numerator and I know the denominator, so what do I want to return? I want to return the numerator divided by the denominator. But the issue with equality then is if you've done that, what happens if these are floating point numbers and for some reason the different values have a slight difference somewhere? So when you have this numerator divided by this denominator, you get a certain answer, but even though it looks like all you did was multiply the top by something, multiply the denominator by something, the floating point values could be different. And so even though mathematically they're exactly the same, the float values may not be the same. So we have to be really, really careful with our dunder EQ to make sure that it's actually checking to see whether these two fractions have exactly the same values. If we wanted to reduce a fraction, reducing a fraction is not something that is built in. Reducing a fraction is would be a method that we could create ourselves. Let's say that says here's the numerator, here's the denominator. Let's reduce that and return a fraction that's in lowest in like the lowest form, in reduced form. That would not be a dunder method because that's not utilizing or overloading something that's already built in. That's not using existing structure of the that's built into Python. This is doing something extra, doing something specific to our fraction class. So what would it have? It would still have DEF, right? You're still creating the method, and it would be called reduce, maybe. And then you would have self in parentheses with the colon, and then think about how you would go about reducing a fraction. You know the numerator and you know the denominator, and then you would return a fraction with the appropriate new numerator and denominator. But then when you wanted to use this or call this function, again, it's a method, so it's in the class. Methods are called by the dot notation. So right now, if we try to print our fraction, we won't be able to see anything. And so we also want to, we will see something, just not what we expect. If we create a fraction, let's say we create the fraction that corresponds to 1/2, if we print x, then you will see that you don't get anything at all that looks like 1/2. You get information that tells you what kind of thing x is and where x is stored, where it's saved. And so you get a memory location that corresponds to that. And that's not what we want when we say print x. When we say print x, we want something like 1/2 or whatever we choose in that particular context. And so we need a method that will tell Python how to create a string from the data so that it can be printed. So since we're going to be telling Python what to do when the user uses the method or uses the print function, then our method is going to, again, be a dunder method. And so, again, we want to write this method to tell Python how to create a string from our data. And so the method that we create is dunder str. So maybe we just return a formatted string that says the numerator, then a space with a slash, and then the denominator. In this case, there are some concerns, some issues. If we had, say, the fraction 1/2, it would look okay, it would be 1/2. But if we had the numerator being 3 and the denominator being -2, then it would output 3/-2, or 3/-2, rather than the way we would typically think to put the negative with the numerator. And so if both numbers were negative, it would output -3/-2 instead of 3/2. Maybe 0/7 rather than just 0. Maybe we want 0/7, or maybe we want to just see 0 when we print a fraction that's equal to 0. And so with the str method, we can do other things to improve that. So don't just return this formatted string, do some more calculation, do some more testing, do some more conditional statements. If it looks like this, then do this thing. If it looks like that, then do something else, and return something that looks nice in all different kinds of scenarios of using the print function. And so rather than a single line in our dunder str method, maybe we have several situations that we consider to see what happens. And even in the str method, we might automatically print something in reduced form, or maybe we don't. Right? It's up to it's choices that we can make, and it will depend on how we plan to use the fraction class. And so if you're going to use it in certain ways, you would make certain choices at this point, and in different ways, you would make different appropriate choices. So what happens in all of these cases then is that these classes give us a chance to expand and extend Python in ways that maybe no one has ever thought of before. Now, a fraction class is not new, but other kinds of classes, other things that we might want to create that maybe no one has ever thought to create before, we can do from this structure, from this basic starting point of figure out what you want to create, what kinds of data, what the attributes are that are associated with that, and then how do those pieces fit together with other things. And we can build very elaborate classes that can do lots and lots of interesting things for us. So as usual, feel free to ask questions in the comments, by email, or on Discord.